That was the initial molecule, that is amine. And then we have, so in this case there are various steps that we're going to look at and see in some of the reactions, like electrophilic substitution aromatic reactions, whereby you find that the restoration of aromaticity in a compound after a reaction or an interaction with a nucleophile or an electrophile. So in this case we have these kind of resonance structures that occur when, of course, a molecule like an alene is interacting, and this is going to dictate the subsequent reactions of this kind of a molecule. So in this case, this is very basic for the structure of benzene, because next we are going to look at different substituted compounds for benzene, and some of them are going to behave in a different way, in that maybe the electrophile or the nucleophile at this particular point is going to direct or dictate on how a next substitution is going to take place. So in this case, of course, for us to just have a summary of what we have discussed, our basic discussion was centered around the structure of benzene, and of course we have said that there are two representations of the structures of benzene that we can be able to do. And the first one we have said is the Coulomb structure, that is represented like that, and then the second one is a Robinson structure that is represented like that. And then we have talked about the aspect of resonancy, and of course one of our videos we talked about the concept of substitution of the hydrogens that are at this specific point. And then when the arene double bond interact with other molecules, either it forms new bonds or there's a bond breakage. Of course, we're going to see that in other molecules, or there's a substitution, or maybe substitution, elimination, etc. But with that one is going to appear in other discussions. So we have this Coulomb structure and the Robinson structure. So we are going to use the aid of them to represent what we have already said. So in summary, this is the structure of benzene. And then, of course, lastly, when we were talking about naming of alkene, as you can see that benzene has got double bonds, so we can just use a different way of giving it, of course, an IUPAC name. But that one is, of course, the recommended one is the one that we have kept on using, because it's the one that is going to be able, or the one that is going to be commonly used in one of the, or in all our discussions. So in this case, of course, as we can see, we have said that it's a cyclic compound. Whenever we are mentioning a cyclic compound, we start with the prefix cyclo, and then number 2, it's a 6-membered ring, so it falls under from the parent alkane series hexane. And then lastly, it has got 3 double bonds, so this is a triene. So if we were to give it a name, of course, we will start with the term cyclo, and then we have the name from the parent alkane series hexa, and then we have, so naming it, we give the double bond the lowest possible numbers combination. So this is, so for that case, for that rule, we're not going to use this anti-clockwise direction. So you use this one for this molecule and say this number 2, 3, 4, 5, 6. So we have the molecules attached for, the double bonds for this arene molecule attached at point number 1, 3, and 5. So this is 1, 3, 5, triene. So this suffix represents an alkane, and alkane, of course. So it is cyclohexane 1, 3, 5, hexa 1, 3, 5, triene. And then we said about this n is not included, especially because we want to eliminate the possibility of a, or maybe a vowel appearing at that point. So for that case, that's it for today, guys. So I hope this topic is going to assist us in trying to interpret some of the subsequent videos that we're going to do. So without further ado, we'll stop there. God bless you. Bye.